Welcome to the second part of section 7.5 where we're still talking about the division properties of exponents. Let's go ahead and do these warm-up problems. I want you to simplify each of these expressions. In this problem here, I have 3 D's on top, 9 D's on the bottom. So the 3 D's that are on top are going to cancel with 3 of the D's on the bottom, leaving me with 6 D's on the bottom. So 1 over D to the 6th. In this one, I have 6 K's on top, 1 K on the bottom, so it's going to leave me with 5 K's on top. I have 2 J's on top, 5 J's on the bottom, so I'm going to be left with 3 J's on the bottom. Here, the x to the 4ths are actually going to cancel out. The y to the 5th is going to come to the top, and the y to the 1st is going to go to the bottom. So that's going to give me y to the 5th and y to the 1st, and then I have my z to the 8th still up top and my z on the bottom. So since I have 5 y's up top, that gives me y to the, and 1 on the bottom, that gives me y to the 4th. 8 z's on top, 1 z on the bottom is going to give me 7 z's up top. And in this last one, I'm going to move that a to the third, negative third, to the bottom. So I have b to the 7th, a to the 3rd, and a to the 5th is going to give me a to the 8th, b to the 2nd. I have 7 b's on top and 2 b's on the bottom, so that's going to be b to the 5th and a to the 8th. Today we're going to look at raising a quotient to a power. So when I have a fraction and it's raised to a power, the numerator gets raised to that power and the denominator gets raised to that power. If you happen to have a negative exponent, you flip what's inside here first and then apply this rule. So for example, we have 3 to the 4th over 10 to the 4th, so you're going to give each of these an exponent of 4. 3 to the 4th is 81, 10 to the 4th is a 1 with 4 zeros. In this one, since it's negative, we're first going to flip, then apply the exponent. Let's try an example. When raising a quotient to a power, what is raised to the power? Both the numerator and denominator. So for this one, we're going to have 4 to the 2nd. And we're going to take x to the 3rd to the 2nd, which is going to be x to the 6th, power to a power. So 16 over x to the 6th. Let's take a look at this one. We have a to the negative 2 over 5b to the negative 2. So we're first going to, like this. Let's do this our way. Let's take and flip the fraction. So we have 5b over a to the 2nd power. Now we're going to take 25, because we're going to apply this to both of them. So 25b squared over a squared. Let's try this example. We have 3x to the 3rd over 6 to the 4th power. So we're going to take 3 to the 4th, x to the 12th, over 6 to the 4th. 3 to the 4th is 81, x to the 12th, and 6 to the 4th, let's do that on the calculator, 6 to the 4th power, and my calculator is dead. So let's bring up this calculator. And let's do 6 times 6 times 6 times 6, and we're going to get 1296. That could be simplified. We could divide the 81 by 3 to give us 27x to the 12th, and the 1296 by 3 to give us 432. And that should be our final answer. Let's look at these and see if they are true or false. 1/7 to the 4th is equal to 7 to the 4th. That's false. 7 to the negative 2, 7 over 2 to the negative 2 is equal to 4 over 7 squared. Well, the negative means we're going to flip this, but still square it. So 2 squared is 4, 7 to the 2nd is 7 to the 2nd, so that's true. For this one, we are going to flip, so we're going to take 7 over 2 to the third power. And here, we're going to take 7 to the third, 2 to the third. So they're writing this kind of strange. They're separating it. 2 to the third is 8, so this one would actually be true. And for this last one, we're going to flip it. So we have 7 to the fourth over 2 to the fifth power. So they want to know if these are the same. This one's going to be false. They're not the same. Homework for this section is on page 444, numbers 33 to 48.